In 8.2, we cover the law of cosines, which is just a simply much more straightforward process than the law of sines. Law of sines has ambiguous case. We have a possibility of having 1, 2, or even no triangles whatsoever. Law of cosines, you get what you get. All right. It's used in 2 instances, It's used when you know all 3 sides. We have side, side, side. So if I knew A, B, and C, then I can use law of cosines to find the other 3 angles. It's also used in side angle side, where I know 2 sides and the included angle. We have 2 different variations of it. They're both derived from the same thing. We have where we find sines, and we have where we find angles. All right. All of these formulas are simply reworking the Pythagorean theorem. Right. And mostly calculator use here. All right, so once you get it set up, it's a matter of you putting it in correctly, the right way in your calculator. Find the missing sides and or angles of the triangle. So I'm going to just sketch it. Angle A, B, C. We know angle A, 30. Side B, so right there. 12. Side C, which is there. 24. So we're side angle side. With the information that you have, you can find side A. All right, so I'm going to teach you how to do it just a hair shorter, and I do mean it's just a tiny bit shorter. If you have A squared, how do you just get A? Well, you take the square root. All right, so that's what we're going to do. We're going to start with the square root. We're going to do A. So A equals... All right, I don't want you to think in terms of A, B, and C. I want you to think of adjacent, in between, words like that. All right, so the side that's next to angle A, 24, squared, plus the other side that's adjacent, 12 squared, minus 2 times both of those, times the cosine of the only angle that you know, 30 degrees. Then that goes in your calculator. I've got this typed in to Desmos, 14.872. And I've got this typed into my emulator, 14.872. Both of these I made sure I was in degrees. So A equals 14.872. So then your next step would be to find any of the remaining 2 angles. So I can find either angle B or angle C. It honestly does not matter. I'm going to find angle B just because it's there. So angle B equals the inverse cosine. All right, now again, think adjacent sides. So we're going to use the 24 and the 14.872. So adjacent squared plus the other adjacent squared minus the side that's across from squared over 2 times both adjacents. And then we're going to put that in the calculator. Okay, I've got this entered in both Desmos and in my graphing calculator. So I've been accidentally using the graphing here, so when you use the graphing calculator to do your calculations, which you can do, it doesn't give you the option to use the previous answer. So I just put it in as a decimal, 14.872, and we get 22.415. And then in my emulator, well, I did something wrong. Well, let's find out what I did wrong. All right, I see where I went wrong on this one. 872. So 23.795, and that's what I got here. 23.794. That has to do with the rounding. On my graphing calculator here, I used the previous answer. Okay, super, super close. I even checked it on this calculator, 23.794. And like I said, on my graphing calculator, because I used the decimal approximation, I didn't use the full answer. I am slightly off. All right, but that's fine. So we're going to say B equals 23.79. Which one was the graphing calculator one? 794. All right, from here, you have 2 of the 3 angles of the triangle. Add them and subtract from 180. So that'd be angle C minus the 30 degrees minus the 23.794. $126.206. The same thing over here, 180. Just so you see both versions, minus 126.206. First example that we did, this was side angle side. And you can look and see that on example B, I have all 3 sides. So we have side, side, side. So side A would be across from angle A. Side B would be across from angle B. And then of course side C would be across from angle C. You pick one of the angles to start with. It's not going to matter which one you use. I'm going to start with A just because I like alphabetical. So A equals the inverse cosine. And I want the sides that are next to. That'd be the 10 and the 7. So 10 squared plus 7 squared minus the side that's opposite over 2 times both adjacents. And then we're going to put that in the calculator. All right, I've got it entered in. Here's what it looks like in Desmos. You can see it down there at the bottom, 27.660. And what it looks like in my graphing calculator. Okay, 27.660. All right, now, choose another angle. I'm going to go alphabetical, so we're going to do B next. So angle B, inverse cosine, okay, adjacent, plus other adjacent, minus opposite, all those being squared, over 2 times both adjacents. And then that is going to go in your calculator. Okay, got this entered in both calculators. Here's what it looks like in Desmos, 40.536, we round correctly. And what it looks like in my graphing calculator, same answer, 40.536. All right, at this point, you know, I forgot what it was, 536. 2 of the 3 angles of a triangle. I'm going to find the third by subtracting from 180. All right, so 180 minus, we're going to go ahead and use that previous answer just so we have a more exact, and then 27.660. 118 or 111.804. 180 minus previous answer minus, now with this one you can scroll back up and highlight. That way you give me a more exact answer. 111.804 which is the same thing, 111.804. Okay, and this one kind of messes with me just a little bit in the sense that I'm not super great with directions, not because it's a particularly difficult problem. So suppose a boat leaves port, okay, travels 10 miles, turns 20 degrees, and travels another 8 miles as shown. So if I didn't see this picture over here, let's say we have port right there. All right, travels 10 miles, okay? All right, to make it easy on yourself, you're going to say it travels due north. So we're going to straight up. All right, and then it turns 20 degrees. So this is 20 degrees off of north. So if I continue that north line, I am turning 20 degrees off of north. Okay, so that gives me a really big obtuse angle here as opposed to the 20 degrees. The biggest mistake is using 20. All right, it took me a long time to kind of gather that. So if we see this picture over here, I can see the 20 degrees off of north. All right, so we travel 10 miles due north, turn 20 degrees, travel 8 miles. And we want to know this distance here. Okay, I have two sides, but I'm missing an angle. All right, well, this is a linear pair. So 180 minus 20 is 160 degrees. Okay, we're going to call that distance between the port and the boat, we're just going to call it x. So x equals, since it's a missing side, really big square root, adjacent squared plus other adjacent squared minus 2 times both adjacents times the cosine of your angle. And then we're going to put this in our calculator. Okay, I've got both of these entered in Desmos and then in my graphing calculator. So in Desmos, okay, make sure you're in degrees, 17.7, maybe 17.730, and you round that. Got it in my graphing calculator, 17.730. Make sure you use your units in miles. All right, then we have this thing called Heron's formula, which is just fancy for saying find the area of a triangle when you know all three sides. So I've got a formula. Area equals the square root of s times s minus a times s minus b times s minus c. S is your semi-perimeter, which is literally just means half the perimeter. So we find this S thing first, plug it in, use your calculator. Use Heron's formula to find the area of a triangle with sides of length 29.7, 42.3, 38.4. So I'm going to draw a triangle because it drives me insane not to. A, B, C, side A, 29.7, side B, 42.3, and C is 38.4. So the first thing we do is you find the semi-perimeter. Okay, I'm going to do it like this just because I don't like writing over 2. So 1/2, 38.4, 29.7, 42.3. Got it in my calculator. What it looks like in Desmos, 55.2. What it looks like in my graphing calculator, 55.2. Now we plug it in. So area equals, give yourself some space here. All right, we have semi-perimeter. Semi-perimeter minus A. At this point, it really doesn't matter whether you use A, B, or C first, as long as you're subtracting from the semi-perimeter. minus b because I'm anal about it, 52. So 29, 7. See, I'm just going around the circle or the triangle at this point. And then it goes in your calculator. I've got this giant square root typed in both calculators. I've got Desmos, 552.318. And then in graphing calculator, it looks like 552.318. So area equals 552.318, and that's in feet, so feet squared. All right, Chicago city developer wants to construct building consisting of artist lofts, triangular lot bordered by Rush, Wabash, and Pearson. The frontage along Rush, we have it right here, 62.4. Frontage along Wabash, which is here, 43.5, and along Pearson, here, 34.1. How many square meters is available to the developer? So we find the semi-perimeter. So half of the perimeter. Showing you in both Desmos and in my graphing calculator. Desmos, answer is 70. In my graphing calculator, answer is 70. So semi-perimeter, the half perimeter, 70 meters. Now we find the area. Semi-perimeter. Semi-perimeter minus one side. Semi-perimeter minus the next side. And semi-perimeter minus the last side. And then that goes in your calculator. All right, now that I've got it all typed in the calculator, I've got it in Desmos, 711.420. Got it in my graphing calculator, same answer, 711.420. We've got our area. 711.420 square meters. So, Law of Cosines. Kind of a scary looking formula, both of them, but they're not particularly difficult to use. You just have to know when to use them. Okay, and this is a formula I do plan on giving you on your formula sheet for your final.